Hello everybody. Today we are going to be discussing what's called an arithmetic sequence. Okay, long crazy word, but pretty simple concept, stuff that we've actually already done, but we're going to look at it from a different context. Okay, so the way that I'm going to open this up, I'm going to open the lesson up with just a simple chart here of data. So you can see here we're comparing two things. We've got years experience and then we have salary. All right, so I've given 7 years here, and then I've given the salary, of course, in thousands. All right, so this would represent 1,000, 3,000, 5,000, and so forth. Okay, so in the first year, you'd make $1,000. Okay, let's hope that that's not the case with any job, but just go with it for this example for right now. So first year is 1,000, and the second year that we're working, we're doing whatever, we'll make 3,000. So it's a nice little jump from here to here. Okay, and then from 3 years we'll make 5,000, and in 4 years 7,000, 5 years 9,000, and so forth. Now, I don't know, maybe you can make a conjecture or not, but what if I asked you right now, could you tell me how much that you would make in 8 years? Okay, now if you answered 15 to yourself, you've done correctly. You figured out where I'm going with this. Okay, now, for me to go from $1,000 to $3,000, what is the amount of increase here? Okay, so it's a +2, right? So you gained $2,000 more dollars for the next year. Okay, then again from 3 to 5, how much money did you go up? Another +2, and then from 5 to 7 is another +2, 7 to 9 +2. You get the idea. 11 to 13 is +2. So if I was to ask you now, oh, hey, what would be this 8th year? You would tell me that it would be 15 because, again, we would just add 2. Okay? So there's this constant here, this number that is never going to change. I keep adding 2, adding 2, adding 2, adding 2, adding 2. All right? Now, let's suppose that I take the data that I've given you, 1 through 7, and then 1, 3, 5, 7, 9, 11, 13. Okay, and we actually plotted it on a grid. So here's what that would look like. Okay, we've got our salary, that's our X values, our years of experience, those are Y. All right, and we've got this right here. Now what do you notice that this makes? It makes a linear graph, right? It makes a graph in which it's increasing, it's going up, and essentially if I was play connect the dots for a moment, yeah, I would make a line. Okay, and I can keep going. If I wanted to take 8, I know that I'm going to be over here somewhere, we'll call this up here 15. Okay, and I'm still on the same line. Okay, so with that said, the idea today is to take what's called a sequence, okay, a strand of numbers with a particular pattern, and how can we relate that back to linear equations? Okay, so let's go ahead and define, first of all, just some key words. Clean board here. All right, let's start with the definition. A sequence. Okay. And a sequence, in all honesty, is nothing more than just a set of numbers with a specific pattern. And you may have even seen this in your earlier school days where, you're given something like 2, 4, 6, 8, ... and they would say, okay, well, based off of what you see, what are the next 3 terms? Okay, so the next 3 terms would obviously be 10, 12, and 14. Okay, and also when back in the days when you did take this class or you did see this lesson, they would probably follow it up with, oh, what's the rule that's going on here? So what was the rule? How did you get to 10 to 12, 14? What made you come up with those answers? Well, the rule again for this example is we're just adding 2 to each term. Okay? Again, we're going to look at more specific sequences, and if I asked you, maybe not the next 3 terms, but if I asked you, what's the 80th term in this specific sequence going to be, you should be able to tell me that. Okay, and at the end of this, you should also be able to tell me what's an equation that can model this, where you would simply just plug in a value and call it a day. Okay, so let's go ahead and look at an example. Okay, so we've got another specific sequence here. We've got 1, 4, 7, 10, 13. Okay, now just for some basic terminology here, just so that you know what we're going to be saying in a few moments, these individual items here in the sequence, so the 1, the 4, the 10, the 13, and whatever other numbers that you continue, those are all called terms. Okay, every single one of them is a term. Okay, now the very first term is special. Okay, that's going to get its own little notation. So the way that we're going to denote that this is the first term in what we call a sequence is with the following. It's a little a sub 1. And again, a sub 1 refers to the first item in the sequence. Okay? So in this case, our a sub 1, our first item in the sequence is just 1. Okay? So again, I'm calling this a sub 1. And then from here, you can actually label everything else if you wanted to. I can call this 4 a sub 2, meaning it's the second term in the sequence. A sub 3, a sub 4, a sub 5, and of course, dot, dot, dot. The dot, dot, dot signifies that it goes on forever. Okay? Now, if I asked you now, what would a sub 6 be, meaning that sixth term in the sequence? Okay, can you tell me what that would be based off of what you see? Can you come up with some sort of conjecture, some sort of rule as to what's going on here? Okay, well, a sub 6, the sixth rule, the sixth term would be 16. Okay, now, how did we get 16? Now, if you look at our terms here for a moment, how did you get from 1 to 4? Okay, so we are adding 3. And then you go from 4 to 7, we're also adding 3. We're adding 3 between each term. So I can add 3 and get 16. I can add another 3 and get 19. And the sequence will go on and on forever. And like I told you from a few moments ago, we call that a rule. But we're going to change up your vocabulary. Instead of saying that we have the rule being to add 3, okay, it's now we're going to change our terminology and not call it a rule. The more algebraic terminology is what we call the common difference, meaning what is the difference between all the numbers in the sequence? And here's the one thing about the common difference. It has to be consistent with every term in the sequence. Sequence. Okay, so what does that mean? That means that I can't all of a sudden just keep going, plus 3, and next thing you know I get plus 2, and plus 2, plus 4, plus 5. Okay, it has to be consistent the whole way through. That's how I know that I have what's called an arithmetic sequence. I'm adding 3 to everything. Okay, so let's look at something here. Suppose you're given this. Okay, and I'm asking you, determine if the sequence is arithmetic. Arithmetic. Spelling wasn't really my biggest. Is that right? Okay, we're going to go with it for right now, arithmetic. Now, if you had, all right, 2, let's say 8, and then 14, and then 20, and 26, and dot, dot, dot. Okay? So just to kind of clarify everything, what we've done, what would your A